Hello, class. Today is Friday. Happy Friday to you. We're going to start our second lesson on continental drift. First, we will read over our standard statement. We have 6-8 LST 7.3. We're going to draw evidence from informational text to support analysis, reflection, and research. We will, for 7.ESS.1, we will identify and investigate the properties of minerals, identify and classify a variety of rocks based on physical characteristics from their origin and explain how they are related using the rock cycle. 7.ESS.2, we will construct a model or scale drawing based on the evidence from the rock strata and fossil records for how the geologic time scale is used to organize Earth's 4.6 billion year old history. 7.ESS.3, using simulations or demonstrations explaining continental drift theory and how lithospheric tectonic plates have been and still are in constant motion, resulting in the creation of landforms on Earth's surface over time. 7.ESS.4, construct an explanation based on evidence found in and around Indiana for how large-scale physical processes such as the karst topography and glaciation have shaped the land. 7.ESS.5, we will construct a model diagram or scale drawing of the interior layers of the Earth. We will identify and compare the compositional chemical layers to the mechanical physical layers of the Earth's interior, including magnetic properties. For those that don't understand that in English, I also have it written here in Spanish in your speaker notes. I can statement. I can describe the historical developments that support the plate tectonic theory, how rocks are formed, and how the surrounding environments shape Earth as we know it. So I can know how the Earth's crust moves and forms landforms. I will have it when I can explain continental drift theory, tectonic plate theory, and how rocks and fossils are formed in my own words. For Wednesday, Thursday, we're going to be doing slides 4 through 9. Some of the essential questions that we're going to keep in mind and revisit to answer at the end of this lesson is, who is Alfred Wegener? What is the historical evidence that supports the theory of the continental drift? And what causes the movement of the continents? We are going to move down to Friday's slide, actually. So we're going to be reading slides 14 through 17 and completing that on Friday. Okay? So pardon me when I make this just a little bigger, because even with glasses, I'm a blind bat. Okay? Now I'll make it smaller as we go through. You're going to look at the Earth's diagram, Earth's continents, on the next page. What do you notice? Do you think some of them, especially South America and Africa, look like a puzzle? A scientist named Alfred Wegener thought so too. He was a German meteorologist and geophysicist. Wegener first proposed the theory of continental drift, which was an idea that all the continents that the continent was once joined together as one supercontinent named Pangaea before breaking apart and gradually drifting to their current positions. In addition to the puzzle-like shapes of the continents, Wegener had other pieces of evidence to support his theory, which was the location of identical fossils on two separate continents. Fossils are remains of something that was once living that is preserved in a rock. It would not make sense to have identical fossils to exist on two continents separated by a vast body of water. Cynogatheus is a dead mammal-like reptile. This name literally means dog jaw. Cynogatheus was as large as a modern wolf. He lived in the mid-Triassic period, which is 250 to 240 million years ago. It was found as a fossil only in South Africa and South America. Lystrosaurus, which literally means shovel reptile, was on land leading in the early Triassic, 250 million years ago. It was thought to have been herbivores. It's about a meter in length and has a stocky build like a pig. Fossils of the Lystrosaurus are only found in Antarctica and South Africa. The Glossopteris was a woody seed-bearing shrub or tree. It was named after the Greek account of the tongue. A picture of the shape of the leaves. Some reached 30 meters tall. It changed during the early Permian period, 299 million years ago. It went on to become the main specimen throughout the period. It does not become dead until the end of the Permian period. Fossils are found in Australia, South America, South Africa, India, and Antarctica. The continents of the southern hemisphere are rebuilt into a single landmass, Gondwana land. The spreading of the four fossil types form straight and constant patterns of spreading across the inland routes. Okay, right here we have a question that you're going to answer. According to the passage, how many fossil species were looked at to develop the theory of the continental drift? So how many species do we have here? We have the Cynogathus, the Lystrosaurus, and the Glossopteris. Go ahead and give me a quick sentence on that answer. Those that don't understand what I'm saying, we have it in Spanish. You can go ahead and look that up. The continental fit. The continents, particularly South America and Africa, fit together like puzzle pieces. This was another piece of evidence that the continents were once joined. The theory of the continental drift. So right here, we're going to answer some questions. They're multiple choice questions. You can take and highlight them or change them to a different color to show what your answer will be. What is the best title for this passage? How continental drift works, fossil evidence in support of continental drift, landforms in continental drift, all forms prove continental drift. Why couldn't the Mesosaurus swim to another continent? Was it because why couldn't the Mesosaurus swim to other continents? Was it Antarctica, India, and Africa where it was found? Antarctica, India, and America where it was found? South America? Was it North America, Antarctica, and South America? Or was it India, Asia, and South America? So we want to know One, why couldn't it swim to another continent? Then you're also going to tell me where it can be found. Where can fossils be found of the Lysosaurus? It didn't have. Okay, I see what happened. There we go. That makes sense. Okay, I will go in and fix that as well. But so the Mesosaurus, why couldn't it swim to another continent? It didn't have directions. It was too far. The ocean was covered in ice. It didn't have the correct body parts or physiology. Where can fossils be found of the Lysosaurus? Antarctica, India, South Africa, Antarctica, India, South America, North America, Antarctica, South America, India, Asia, or South America. Let me see if I can make that just a little bigger for you guys too. And finally, on slide 17 today, I want you to refer back to your essential questions and to the videos. Answer your essential questions. Then in yellow, you're going to highlight or change the letters to that color that show that there is evidence of continental drift. Okay, and in red, you're going to highlight or change things that do not support continental drift theory. Okay, if you have any questions, feel free to ask away. I'm just going to move this up a little more here. All right, so we are done for Friday.